The Space Buff will be giving a speech on the Math Science Laboratory, the Rover Curiosity. He has asked for 5 to 7 minutes to inform us about the latest mission to Mars. Ryan?
Thank you, Jessica. Fellow Toastmasters and honored guests today. I'm going to be talking about the Mars Science Laboratory as it hurls to its destination. After months of hurtling through the icy stillness of interplanetary space, the rover Curiosity enters the upper reaches of the Martian atmosphere. Cut off from direct communication with Earth, the spacecraft is set to land on autopilot in 7 minutes of terror. The blast from the atmospheric friction is deflected by the heat shield, which is then jettisoned. A supersonic parachute springs out and slows the craft to 200 miles per hour while it makes S-turns above its 12-mile wide precision landing zone. The parachute is cut and the retro rockets fire until the payload is only dozens of feet above the surface of the planet. Finally, the rover descends spider-like on cables of a sky crane where its wheels touch down on the foreign planet. The simple tones of success are received back on Earth 13 minutes later by mission control. To borrow a phrase from gymnastics, which we've seen in the Olympics recently, Curiosity stuck its landing. And by doing that, it is a $2.5 billion success and is about to enter its science phase. My speech has two parts. One is about the overview of the mission to Mars, and two is about the science instruments on board. Curiosity was launched from Cape Canaveral, Florida on November 26, 2011. It touched down 36 weeks later in the wee hours of August 6, 2012, just recently after a harrowing descent into Gale Crater at the foot of Mount Sharp. The landing zone was chosen years in advance by scientists studying satellite imagery due to the presence of clay and sulfite minerals, which are telltale signs of a wet history. This rover builds on the success of previous missions to Mars, including the 1997 Pathfinder mission, the 2005 Mars Reconnaissance Orbiter, and the twin 2003 Spirit and Opportunity rovers, which are still functioning and driving on the surface of Mars today. Curiosity is about twice as long and 5 times as heavy as the previous rovers. It inherited many traits from them, including 6-wheel drive, a rocker bogie suspension system, and cameras mounted about human eye height on a mast. Unlike earlier rovers, Curiosity carries equipment to gather samples of rocks, process them, and distribute them to onboard test chambers. Giving up the solar panels of previous rovers, Curiosity's electrical power will be supplied by a U.S. Department of Energy's radioisotope power generator. In other words, it's got its own nuclear power plant on board. The design mission duration is a full Mars year, which is equal to 687 Earth days. It will communicate with Earth via the Mars orbiters used as radio relays. The science goals of the craft are to investigate whether the landing area has ever had environmental conditions favorable to microbial life and its fossil preservation. While previous rovers have literally bumped into the Martian surface, cocooned inside airbags, the precision landing used for Curiosity will be important for later missions, both to pick up rocks on Mars and send them back to Earth, and conduct more thorough surface exploration for Martian life. I looked up a lot of information online on the Mars website of the Jet Propulsion Laboratory of NASA's Space Laboratory. And it talked about the instruments on board and the mission scientists who are going to lead up the mission and each of the tools that are going to be used. A suite of instruments inside the body of the rover named Sample Analysis at Mars will analyze samples of material collected and delivered by the rover's arm. An X-ray diffraction and fluorescence instrument called ChemIn will identify and quantify the minerals and rocks and soils and to measure the bulk composition. Mounted on the arm, the Mars Hand Lens Imager will work like an earthbound geologist to examine extreme close-up pictures of rocks, soil, and if present, ice, revealing details smaller than the width of a human hair. The alpha particle X-ray spectrometer will determine the relative abundances of different elements in rocks and soils. And the mass camera, standing about 6 foot 9 inches tall, about the height of a basketball player, will image the rover's surroundings in high-resolution stereo and color. A laser named ChemCam will vaporize thin layers of material from targets on rocks or soil up to 30 feet away. So it's almost like those 1980s science fiction movies and shows on TV where it's literally going to blast its way into science. It will include both a spectrometer to identify the types of atoms present and a telescope to capture detailed images of the area affected by the beam. The rover's radiation assessment detector will categorize the radiation environment at the surface of Mars. This could possibly be the most important experiment that Curiosity does while it's on Mars in advance of human exploration. The information is necessary and relevant to assessing the planet's ability to harbor life. Spain contributed to the mission, and it contributed the instruments of the Environmental Monitoring Station used to measure atmospheric pressure, temperature, humidity, winds, and ultraviolet radiation levels. Russia is providing the Dynamic Albedo of Neutrons instrument to detect hydrogen up to 3 feet below the surface. Detections may indicate the presence of water in the form of ice or bound in minerals. It's important to know if Mars ever had life. Based on the circumstances, we know it to occur in the presence of water and with carbon-containing compounds. And this instrument will help us determine how much water is just below the surface of Mars. Other equipment includes tools to remove dust from rock surfaces, scoop up soil, drill into rocks, and collect powdered samples from rocks' interiors, sort samples by size with sieves, and deliver samples to laboratory instruments on board the rover. Additionally, the entry, descent, and landing instrument suite measured atmospheric conditions and the performance of the spacecraft on entry to aid in the design of future missions. Currently, Curiosity has had a successful brain transplant where the mission control on Earth has updated its onboard software from the flight stage between Earth and Mars to the driving and exploration stage, the science phase, which it is beginning now. In the week to come, it will be testing the driving machinery. Then it will pick targets for investigation, drive to them, and begin testing its robotic tool-wielding arm. And to conclude, when considering the success rate of spacecraft arriving at Mars is less than 50%, Curiosity is already making good on its $2.5 billion investment to test new engineering practices and advance the knowledge of habitability for microbial life on the planet. In the weeks and months to come, this rover will show us the best that mankind can do in exploring another planet and paving the way for future missions to Mars. Madam Toastmaster? And I've got a picture here to pass around to show you what the Curiosity rover looks like.